steering committee and scientists have identified as being extremely important to this process. In terms of river inputs, the assumption we're making, and when I say assumption, I mean that that is going to be the same in each of the 4 scenarios. So when we're making an assumption, this will carry across all 4 scenarios, whereas the uncertainties that are represented on the axis will change from scenario to scenario. So the assumption for river inputs is that extreme river flow events will be comparable to present day or increase as climate change occurs. Now, any of you that are familiar with climate change models are going to know that, you know, it's kind of up in the air in terms of what the actual shift in precipitation patterns may be. But the reason we're focusing on the potential for increasing extreme river flow events is because our stakeholders, particularly our city planners and our natural resource managers, have realized that if storms become more common, they will have to change how they manage the system. If storms become less common, it's probably not going to be that big of a deal in terms of how we manage the system from day to day. So we're looking for these scenarios to not only be plausible, but to be a useful exercise for planners to really think about how they may actually have to change how they manage a system. And so the uncertainty for river inputs will annual average river flow increase or decrease? And then for the marine inputs, our assumption is that climate change will cause sea levels to rise, and our uncertainty is that will tidal prism increase or decrease? So this gives us 4 scenarios that we will be working on developing in more detail over the next month or 2. And so what does this all get at? What are we really trying to find out when we're doing a vulnerability assessment? We're trying to find out how resilient our system is. And when our vulnerability assessment is done, the most resilient systems are going to